Alright, so we're going to work on solving a three unknown, so x, y, and z, three equation system. You have to have the number of equations that you have unknowns in order to be able to solve. So we can solve x and y, two unknown with two equations, three unknowns with three. So what I would recommend is that sometimes it helps for people to number. This is not required. But we're going to do what we think of as a double elimination. So we're going to eliminate one variable two different times. So we cannot eliminate two separate variables. We got to pick one and eliminate it twice. So you have to look ahead. And if we look down the x's, remember we are eliminating. So that means that you add down the columns. When I add, I want to have the same coefficient, opposite signs, in order for them to go to 0. So x's would be fairly simple. First and third equation I could eliminate just by adding, and then I could just multiply by 4 in order to eliminate with the second, so that's an option. Y's would be extremely easy because they're already the same coefficient with some opposite signs. Z's would not be easy, although this one is very flexible, but that would definitely be my last choice. So the easiest, most efficient for this problem would be the Y's. So we're going to pick two equations. I'm going to pick the first and the third because we've got a -5 and a +5. When I add down the columns with the first and the third, that's going to eliminate the x's. Well, that's extremely nice. Eliminate the y's, and then it's going to give me -6z equals -18. This will not always work out to be this simple, but this goes straight to giving me z equals 3. Definitely highlight, box, star, somehow so that you know you found one variable. I then have to go through, and I'm going to do the same process, but using two different equations. Now, I have to use equation number 2. Does not matter which of these, so use which one makes the most sense. So since I'm eliminating y's again, I'm going to pick the first and the third. So I'm going to add down. Let's get it back in focus. There we go. 4x plus 1x is going to give me 5x. The y's eliminate. We have 3z, and that's going to be equal to -1. Now, typically, we would have two of these two unknown equations that we would then solve even further using substitution or elimination. But since the first one worked out so nice, I know that z equals 3. I'm going to substitute that right in here, and I'm going to go ahead and solve it. So 5x plus 3 times 3 is -1. You can simplify in fewer steps. I'm just showing you everything. So 5x is -10. That means x is -2. Once again, highlight, box, star so that you know you have two of the three. I'm missing y. Now for that third step, you always have to go back to one of the originals. Does not matter at all which one you plug it into. I usually go for the simplest number, so I'm going to pick equation 1. So -x, so x is -2. I'm going to plug that in. Minus 5y, I don't know what y is. Minus 5z, but I know z is 3. Is equal to 2. And then we just go through the simplification. So 2 minus 5y minus 15 is 2. 2 minus 15 is going to give me -13. Be very careful with your negative signs. Add 13 over. So then y is -3. And then you just have to make sure that you remember to write your final answer as an ordered triple. So we have -2, -3, 3 as my final solution.